Okay, so I heard somebody say number 4. That sounds like a good place to start. So you did okay with the first 3 of them, though. So you get the idea. Yes, Lizzie? What's that? 4 is easy? Okay, good. So we are again looking for a pattern. So we are using our powers of inductive reasoning to solve this problem. And I might skip the last shape, but they basically have quadrilaterals with a different number of sides. And then they are drawing diagonals in here, but they're doing it in a special way. This is a little bit different than the ones we did with the dots on the circles, because they're only drawing diagonals from one of the vertices. You guys see that? And that's important because this is going to be something that we're going to take a look at later on in the course. So if you have 3 sides, how many triangles do you have? 1. Just the one, the original one that you started with. Then if you have a 4-sided figure and you draw a diagonal from one of the vertices, you can only draw one diagonal, and that divides it into how many triangles? 2 triangles. If you have 5 sides, how many triangles do you get?
3.
1, 2, 3. Okay? And you could continue this on. I don't know, do they want you to, I guess you're supposed to do 6. Anyway, we'll figure out the pattern and then do that. So what are these going up by each time? 1. So you know that when we come up with the formula, it's going to be 1n. Okay? And then the way that I've kind of been talking through this with some kids that have been coming in to get help after school and before school is this number right, nope, that's not going to work in this case, never mind. Because now we're starting with 3 instead of with 1, okay? So to figure out what I need to add or subtract, I need to take 3 and plug it into this. What is 1 times 3? 3. But I want the answer to be 1. So what do I have to do to 3 to get 1? Subtract 2. Okay, is that what you meant to say? Okay, yeah, subtract 2. And then you can check and see if that works for the other one. If I go 4 times 1 minus 2, do I get 2? Yes. 5 times 1 minus 2, do I get 3? Okay, so what we figured out then is our formula for n, for any number of sides, it's the number of triangles is going to be 2 less than the number of sides. Okay? And then they want you to extend that and answer the question, so what if, use that to figure out what if we have 35 sides, how many triangles will we get out of that? 33, yeah, because 35 minus 2 is 33. Okay? So you guys that came in and were, I don't get this, what was the, where did you stumble on this? What was the part that was confusing to you? Was it finding the number of triangles, or the formula, or coming up with the formula part? Okay, so you could fill in the table, but then the formula was a challenge. All right, we'll keep working on that. Number 7. All right, number 7. Yeah, that's a good one. So I'm not going to draw out the shapes. You have it in your book. So we have some figures drawn, and they're using matchsticks. And so we want to do 2 different things: figure out the pattern for the number of matchsticks, and then also figure out the pattern for calculating the perimeter of the shapes. So this goes up to 3, 4, 5, 6, and then we have 10. 200. Okay, so in the first figure, it says that you use 5 matchsticks, and since all the matchsticks are on the outside of the shape, if you count one matchstick as 1, what's the perimeter of that shape? 5. Okay? Now for the second figure, they're going to put another pentagon next to it. How many matchsticks did I use now? 9. But now do you see good that the perimeter is no longer 9 because one of these matchsticks is on the inside. So there's only 1, 2, 3, 4, 5, 6, 7, 8 matchsticks around the side of it. Okay? Is that as far as they filled out for us? Yeah. So now we need to come up with the rest on our own. So how many matchsticks would you need to make the third figure? What's that?
13.
And how'd you get that?
That's added.
Added what?
4.
Added 4 on there, yeah, and you can see that by the way you would physically draw the next figure. You would have to go 1, 2, 3, 4 matchsticks onto there, so you'd have to add another 4 matchsticks. What is the perimeter now of this new shape?
11.
11, and how'd you get that?
Added
Added 3, okay? So Byron has this figured out, and this is the easy part. These numbers are going up by 4s, and these numbers are going up by 3s, okay? So if I keep going up by 4s, this would be 17, 21, and 25. And if I keep going up by 3s, that would be 14, 17, and 20, okay? So that part should have been not too bad, okay? And then you guys said this is the hard part, is finding the formula. All right, so the first step is, what are we going up by here?
4.
4. So what does that tell me my formula starts with?
4.
4n, good. So then the tricky part is, yeah, how do I get a 5 out of 4 times 1? You have to add 1 onto that, okay? So this should be 4n plus 1, okay? And I don't know a different way to, I don't know, to explain that part. I think, is the number in front of the n, is that pretty easy to see? It's the, what do you add or subtract from that that's hard? Okay. So this one is going up by 3, so it's going to be
2.
It's going to be 3n, because it's going up by 3s. And then again, if I look at this number right here, 5, what do I have to add to 3 to get 5? 2. So 3n plus 2. So that's where those formulas come from. Okay, and then now the nice thing about having this formula is we do not have to take the time to draw the 200th figure to figure out the answers to these things. I can just take the 200 and plug it in. So if I take the 200 and plug it into the matchstick formula, good, 4 times 200 is 800, and then I have to add 1, so that would be 801. And then if I take the 200 and plug it into here, I get 602. Okay? We're getting closer? Understanding?
Yeah.
Yeah?
13.
Okay.
Yeah, I need 13.
All right, so that was it on the finding the formulas. And we'll keep reviewing those. We're going to do more with this today as well. Okay? All right, so then these were, the rest of them were reviewed. You said which one?
13.
13. Okay, so we are going to sketch and carefully label a figure. Okay, a cube with a plane passing through it. So I'm going to go backwards here and I'm going to draw the plane first, because I think that's kind of the hard part. So there is my plane. Okay, there's the plane. So can you kind of get the sense that that's coming out at you? Sort of, all right? And then now I'm going to build a cube around that, and it might just be a horrible cube, but you take what you get. So there's the top of my cube. My problem is it's going to not really look very cubish because it's too tall already. But what are you going to do? Optimus Refornia. Not an art guy. Alright, so there is my cube with the plane going through it. Does that make sense? Kind of? Okay. And then there's some labeling we're supposed to do. The cross section is rectangle RECT. So I need some more dotted lines here. So I have a little rectangular cross section here. Making things worse. R, E, C, T. Okay? That's as good as it's going to get. Sorry to say. All right, trade your papers with somebody and let's correct them real quick. Ready? All right, number one, the formula is 6n minus 3, which means the 20th term is 117. Number two, the formula is negative 3n plus 4, which means the 20th term is negative 56. You can go half point for each one of those. Did they get part of it? Yeah, okay. Number three, the formula is 8n minus 12, and the 20th term is 148. 4 we did on the board, the formula was n minus 2 and the missing number is 33. Number 5, the formula comes out to be 8n, which means the number of tiles for the 200th figure would be 1600. Good thing we didn't have to draw that. And number 6, the formula is 4n minus 3, and the number of tiles that you would need for the 200th figure is 797. All right, we did 7 together, so everybody got that right. Then what did we do for sketches? 11 through 14? Or just through 13? Oh, okay, good. All right, so number 11 says a equilateral triangle. We'll start with that, and they want us to label it EQL. And then it says with segment QT, so T lies on the side EL, so that should be over here. And QT is perpendicular to EL, something like that. You could have it rotated a different way, but there's a line going from Q to the opposite side, T, and that makes a 90-degree angle. Okay, and then number 12 says an isosceles obtuse triangle. Start with that. OLY and OLY looks like this because OL is congruent to YL with angle bisector LM. So if I have an angle bisector LM, I need to know that the two angles that it makes are congruent, and I need to put a point M on there somewhere, okay? So it should look something like that. And then number 13, be nice to them with that crazy cube thing. That was a little bit tricky, all right? All right, so I think that is, 10 problems altogether? So put their scores on them and give them back, and then pass them forward.